Hi. When we left off at the end of the previous video, we had been working through an example looking for a correlation between the temperature and the number of calls to an emergency service. And we had a set of 7 data points, and we used that big ugly formula to calculate the correlation coefficient R. Now I'm going to show you how you can do that in Excel. So I've got Excel opened up here, and I've typed in my data points here. 68.7, 74.4, 82.8, and so on. I've also put in the headings, which you don't have to have, but I did anyway. Now, if you go to a blank cell somewhere and type the following, equals CORREL, that stands for correlation coefficient. Now, parenthesis, and I have to give it, first of all, where my X numbers are. Here I have them in cells A2 through A8. So I'm going to type in A2 colon A8. Then a comma, and then I'm going to type in where I have my Y values, and they are in cells B2 through B8. So B2 colon B8. And then when I hit enter, the number that shows up is 0.811368858, the same number we got when we calculated it from that big ugly formula. While we have our numbers in Excel, let me just select all of these and insert a scatter plot. Just going to pick the first scatter plot here, and that generated for me a scatter plot for this set of data. There's my 7 data points, and we can change the title if you want, or just delete it. We can label the axes, we could change the scale, change the way the dots look. There's things you can do to format it, but there's your basic scatter plot that Excel made for me automatically. Now let me also show you how you could take advantage of some of the special graphing calculator functions to ask it to draw you a scatter plot and calculate your correlation coefficient. So I'm going to push the stat button, and I'm going to edit some data. Right now, I don't have anything in here. If you have some numbers already stored in your calculator's memory here, and you want to get rid of them, you'd have to push stat, go down to clear list, and tell it which list to clear. Like L1 would be the first list. So I got that by pushing the second button and the 1 key that says L1 above it. So that should clear out the data in list 1. So now I'm going to type in list L1 my X values, 68, 74, 82, 88, 93, 99, 101, and then go over to list 2 and type in my Y values, 7, 4, 8, 10, 11, 9, and 13. Now, here's how I would ask the calculator to draw a scatter plot for me. First, I'm going to set up the window. Notice that my X values are all somewhere between 68 and 101, and my Y values are all somewhere between 4 and 13. So when I set my window, yours might not look exactly like this. I was doing something for another class, but make sure your X min and X max, whatever you set them to, all of your X values should fit between them. You could start the X's at 0, or you could start them just somewhere below your lowest value. So maybe I'll start at 60, and my X max should be somewhere above my biggest value. So maybe I'll go up to 110. And then for my y's, I will go from, how about 0 to 15? Just make sure that all of my y values fit between the numbers I put in for y min and y max. Now I need to turn on stat plot. So push the second button and then the button that says stat plot above it. Right now it's off. I want it to be on. So I hit enter and then I'm going to hit enter again while it's on. And it should look like this. Your X list should be L1, your Y list should be L2. Now let me warn you about something. When you're done with all your scatter plotting, you should probably go back in and turn this back off. Because otherwise, somewhere down the road, you're going to be in another class, maybe an algebra class, you're going to want to graph an equation with your graphing calculator, and it's not going to work. And that's because you'll have stat plot turned on, which means your calculator will be in stat plot mode instead of the kind of mode to draw just ordinary algebraic equations. So for what we're doing here, we want this to be on, but for other things that you might be doing for your graphing calculator in other classes, you'll want it back off. Okay, now let's go ahead and we can adjust the type if we want, but we want the first one, the scatter plot. And now I'll just go ahead and hit graph, and there it is. It does look like what Excel gave me. I had the scale a little bit different, but same basic idea. There's my 7 data points. And how do I get my correlation coefficient? Well, there's something you have to set on your calculator before it will show you the correlation coefficient. To set that thing, push the second button and then the 0 button that says catalog above it. And you'll see something like this. And you will want to use the down arrow button to scroll down through the list until you find diagnostic on. These should be in alphabetical order, so when you're in the D's, there's diagnostic on. While we're pointing to that, we hit the enter button, hit enter again, and it'll say done. You only have to do this once. Once you've done this one time, your calculator should be good to go from then on. So now that we've done that, here's how to see what the R value, the correlation coefficient is for those numbers that we entered in. Push stat, go over to calc, and go down to number 8 on the list, lin reg a plus bx, and hit enter. And I think this is what we want, but your X list should be L1 and your Y list should be L2 because that's where we put in those numbers. Just go down to calculate, hit enter, and here's what it shows us. The number at the bottom, R, equals 0.811368858 and so on, just like what we got in Excel and just like what we got when we calculated it ourselves from the formula. This also gave us numbers for A and B that we are going to be talking about in section 10.2. So when we get to that and we talk about the A and the B for the linear regression line, here's where you'll find those on the graphing calculator. Okay, so now I've shown you 3 different ways that you could find this correlation coefficient. You could use this big ugly formula. You could use a spreadsheet program like Excel that has that function available, or you could use a graphing calculator. And there are other things you could use. There's other statistical software or apps that can do this sort of thing for you. So in reality, you only really need to know one way of doing this that works for you. moving on, once we have this number, what does it tell us? I mean, 0.811, is that good? Is that bad? Is that big enough? Well, based on the sample, we want to know whether there's a relationship in the population that the sample represents. Are the two variables related in general and not just for those specific data points you looked at? Like, do higher temperatures mean more emergency calls in general as opposed to just on those specific 7 days that we looked at? Are those 7 days enough for us to generalize and say that, hey, as a general rule, when the temperature is higher, there tend to be more emergency calls? Well, this brings us back to hypothesis testing. Remember how that works. In this particular situation, the null hypothesis is that rho equals 0. Remember, rho is the population correlation coefficient. So the null hypothesis would be saying that there is no correlation between the x and y variables in the general population. And the alternative hypothesis is that rho is not equal to 0, that there is a correlation, maybe positive, maybe negative, but some sort of correlation between the variables in the general population. So if we could look at not just those specific data points, but all the data in the whole world, we would still see a correlation. Now there's different ways we could do the hypothesis testing. We could do it by going through the steps, finding a p-value or all that good stuff. But the easiest way to do this particular kind of hypothesis testing, where you're testing that rho equals or is not equal to 0, is by using table I. So this is another table that we haven't looked at yet, but it's one of the tables in the back of your book. And I've included a copy of it on your notes at the end of the notes. It looks like, well, here it is, table I. Critical values for the PPMC. And it explains at the top of the table how to use it. So running down the left column here, it says DF, and then it gives a bunch of numbers. And up at the top, it explains that DF equals N minus 2. So that's a little bit different from what we've seen before. We are used to DF being N minus 1, your sample size minus 1. But here, because we have two variables, DF, your degrees of freedom, is going to be in your sample size minus 2. So in this example, N was 7. We had 7 pairs of numbers. So degrees of freedom will be 5. And then we have a column for if alpha is 0.05 and a column of the table for if alpha is 0.01. So either one of those could be your level of significance. And then you reject the null hypothesis that rho equals 0 if the absolute value of R is greater than the value given in the table. In the example we just did, the number in the table is 0.754. R was 0.811. So R was greater than the value given in the table, and so we would reject the null hypothesis. And then step 5, if you rejected the null hypothesis, you can say that there is a significant relationship between the variables. And then in the next section, we'll talk about what to say about that relationship, how to come up with a formula or an equation. And if you did not reject the null hypothesis, there's not enough evidence to say there's a significant relationship between the variables. So here we did reject the null hypothesis, so we can say there is a positive relationship between temperature and number of calls. Okay, back in the next video for another example or two.